At the scene of the crime, a burglar has just broken in. She's creeping stealthily down the hall, grabbing the purse on the counter. Suddenly, she knocks over a water bottle. No big deal, right? Think again. As she picks it up, she leaves behind invisible evidence that she was here. Her fingerprint. If you know how to make these prints visible, the DNA will point to her, landing her in jail. How can we identify these fingerprints while not breaking the bank with $1,000 equipment? Will a cheap, homemade solution work just as well? Let's find out with my science fair project. Step 2. Background research. Welcome to the background research section of my science project. Today, I'll be using Screencastify to explain to you the different areas of research I study to fully understand forensic science and how to carry out my experiment. Before we start, what needs to be understood is that usually, before other methods are used, fingerprints are invisible, and each person's are unique. You must also know that forensic science is the application of science to criminal investigation and prosecution, often by using DNA, fingerprints, or other material to prove someone guilty or not guilty of crime. My first topic of research is about forensic light sources and their uses. This website is from Horiba Scientific, and it describes all the benefits of these lights versus the traditional dusting and lifting fingerprints, and explains what they are and what they can do. I learned that a forensic light is an ultraviolet tool that causes certain things to fluoresce or glow. Some of these things include dyes, stains, and body fluids. Identifying evidence with a forensic light source is often more effective than the print dusting and lifting, because it works well on surfaces that are impossible to dust on, such as heavily grained wood and smooth, shiny paper. Now that I know the basics of what I'm dealing with, it's time to learn about my experiment, including the different steps. This brings us to my second topic. Before you start the experiment, you have to know what steps are involved. This website, Instructables, shows a DIY way to do the first step of identifying fingerprints: cyanoacrylate fuming, or superglue fuming. Here, I learned about the fuming process and how to do it without special equipment. It works like this. When superglue is heated and vaporized next to an object with fingerprints on it, the ingredient cyanoacrylate sticks to the fingerprint and reveals it with a white film over the edges. There are multiple items needed, such as a fish tank and small heater. But this is very convenient compared to what other professional companies use, equipment that can cost thousands of dollars. In this website, I learned everything I need to know about Phase 1 of the project. My third topic of research is an article written by C. Taylor on sciencing.com. This website describes the step-by-step process of using a forensic light source, such as a black light, to reveal fingerprints when used with special dyes. This takes place after the fuming process has been done. From this site, I learned that certain conditions and materials are needed, such as lowering the light in the room, and getting a forensic light, a dye called basic yellow 40, and wearing UV protective goggles so your eyes won't get burned by the UV rays. As listed, first, you submerge the object in a dye solution, then lower the light, then put on your goggles, shine the light on the object, and view it. When the dye sticks to the superglue film and the light shines on it, a clear, fluorescent image of the print is visible. This would be the perfect evidence to convict our thief of the crime. Now I know about fingerprints, forensic light sources, superglue fuming, and dye staining. But which dye should I use? There are many available, but which is best for my project? This is where resource number 4 comes in. This website is from BVDA, and it explains all the different staining solutions, including their attributes, what light they fluoresce under, and what protective eyewear is needed. Basic yellow 40, basic red 14, Ardrox, Safranin O, and rhodamine 6G all had their benefits, but some were immediately out of the picture, either because they were too rare, too expensive, or required equipment that was not easy to get. After reviewing all the choices, I learned that basic yellow 40 was the smartest choice, because it fluoresces well under blue light, it is less expensive, and can be bought at almost any online forensic store. The next thing I searched was the cost of glue fuming chambers at Searchy.com, so I could compare project costs and see if I'm being cost effective or not. What I found was that these chambers can range from $250 to over $1,000. A laboratory kit similar to my fuming chamber costs $232, as opposed to the approximate $100 my entire project, including chamber, staining materials, and everything else would cost. For my final research topic, I decided to learn about the safety risks of ethanol alcohol, the ingredient I'm using to create my basic yellow 40 dye solution. This dye's least expensive option comes in a powder, which requires ethanol in order to dilute it. All safety precautions must be considered, and I want to be properly prepared. In the status sheet, I learned that ethanol is flammable, so I need to keep it away from heat sources or open flames. It needs to be kept cool in a well-ventilated area. Most importantly, it should not be touched, inhaled, ingested, or put in your eyes, because any of these could seriously jeopardize your health. Gloves, safety glasses, and a mask are all necessary. The mask is needed because most ethanol solutions also contain methanol alcohol, which can damage your eyesight if touched or inhaled. All these research topics have helped me to better understand my experiment. With what I've learned about forensics and forensic light sources, cyanoacrylate fuming, dye staining, different dye types, fuming chamber costs, and safety precautions for ethanol and methanol, I am now prepared to begin the project. Step 3. Specify requirements.
For phase 1 of the experiment, you'll need the following materials. First, the fingerprint object, which is probably the most important part. Next, a small coffee or tea warmer. This provides a heating surface for the superglue to melt with. The superglue. Make sure that it contains cyanoacrylate. Most strong glues do, but always check the label to be sure. Also, follow all the safety precautions listed. A small amount of tin foil. I chose tin foil because it is disposable, so you don't have to worry about ruining it when the glue melts down. A small cup of water to add more moisture to the tank during fuming. This will speed up the process. A fish tank or other transparent item that can be viewed from the outside and sealed, where the experiment will take place. A fitted cardboard lid that will fully cover the top of the tank while the glue is melting. Make sure to include a small hole at one end for the coffee warmer cord. And finally, duct tape to seal the lid to the fish tank so no fumes will escape. For phase 2 of the project, you'll need the basic yellow 40 fluorescent dye to make the fingerprints visible, the blue fluorescent blacklight with suggested wavelength of 365 nanometers or more. Higher wavelengths detect more fluorescent light because they're in the UV spectrum. UV protective goggles to prevent you from burning your eyes with the ultraviolet light. Ethanol alcohol, used as the base in your dye solution. Try to find an alcohol mixture with little or no methanol, as this chemical is dangerous to your health. A gram scale, used to measure your dye. And a small bucket, used to dip the object in the solution. For phase 2 of the project, you'll need the basic yellow 40 fluorescent dye to make the fingerprints visible, the blue fluorescent blacklight with suggested wavelength of 365 nanometers or more. Higher wavelengths detect more fluorescent light because they're in the UV spectrum. UV protective goggles to prevent you from burning your eyes with the ultraviolet light. Ethanol alcohol, used as the base in your dye solution. Try to find an alcohol mixture with little or no methanol, as this chemical is dangerous to your health. A gram scale, used to measure your dye. and a small bucket used to dip the object in the solution. For phase 2 of the project, you'll need the basic yellow 40 fluorescent dye to make the fingerprints visible, the blue fluorescent blacklight with a suggested wavelength of 365 nanometers or more. Higher wavelengths detect more fluorescent light because they're in the UV spectrum. UV protective goggles to prevent you from burning your eyes with the ultraviolet light. Ethanol alcohol, used as the base in your dye solution. Try to find an alcohol mixture with little or no methanol, as this chemical is dangerous to your health. A gram scale, used to measure your dye. And a small bucket, used to dip the object in the solution.
Now that you know what you need, let's find out the cost and where to buy it. I already had a few of the items at home: the glue, fish tank, foil, and small bottle, so the cost for those were $0. You can find any of these items easily. However, finding the other items was more difficult. The coffee warmer, blacklight, and protective goggles were bought on Amazon, and the ethanol can be bought either on Amazon or at Home Depot. Finally, the basic yellow 40 was the hardest to buy because on most websites it was out of stock. MedTech Forensics is your best bet for this item. Overall, depending on whether or not you have a fish tank or something similar, this project can range from $52 to around $100, which is very good compared to buying professional supplies. Step 4. Brainstorming. For my brainstorm, I used Text2 Mind Map. This is divided into 4 different sections. In each one, I thought about all the different subjects in my topic and what needs to be done for each one. The first section was my 2 main techniques: fluorescent dye staining and glue fuming. The second part goes into more detail, explaining the things I need for each technique. As you can see, for fuming, I need superglue, the fuming container, such as a fish tank, the fingerprint object, a small cup of water, as well as a heating source, such as a coffee heater. For the dyeing and viewing, I need a UV blue blacklight, ethanol alcohol, yellow 40 dye, and a camera. The third section had to do with the cost. Here, I said to get the 30-day free Amazon Prime trial so that I didn't have to deal with the shipping costs. I decided it needed to be under $75, and I listed my most expensive item, which was the dye. It came in at about $20. Finally, I focused on safety and listed that for the project I needed goggles, gloves, and a mask. I realize now that I need something of better quality than a nurse mask, and my camera doesn't need a UV filter, but that's fine. Brainstorming is only the rough draft for your project. Step 5. Developing the prototype.
When I developed my prototype, the first thing I thought about was what I could find around the house that could be used for a fuming tank. Fortunately, I had an available fish tank, which was perfect. Then, I thought about what heating source I needed. A coffee warmer was best because it provides warmth but doesn't have an open flame that can set the glue on fire. I learned that putting a small cup of water in the tank speeds up the fuming. I placed everything in like this. For the second phase, my prototype is just a bucket, the object, and a place to lay it out to dry. I thought about how to put the dye on the object, and a bucket seemed the most reasonable because you can just set it in and wait, then take it out when you're done, and all the fingerprints will get dyed. There's no chance of a fingerprint getting missed when the whole thing is in the bucket.
Step 6. Testing my solution.
First, place the aluminum foil on top of the heater and put on some glue. You don't need that much. Then, put the heater inside the tank and place the aluminum foil on top. Then, put the small cup of water next to the heater and place the fingerprint object as close as possible. Then, to make sure that no fumes escape, you have to put on the cardboard lid. Now, very carefully remove the lid and try not to breathe in any of the fumes. Remove the fingerprint object and prepare for future analysis.
Once you fume it, the fingerprints should look like this, with the ridges visible. This is the thief's thumbprint. Zooming in, we can see the pattern in great detail. On the other side are her pointer, middle, and ring fingerprints. As you can see, when she picked up the bottle, she didn't use her pinky. The close-up is of her middle fingerprint. These are very good samples that will easily convict the thief of her crime. For step 2 of the project, I used a gram scale to measure the dye. With the end of a plastic spoon, I carefully put the right amount of dye in the cup, about 2 grams for the 1,000 milliliter bottle of ethanol. Then, I scraped the dye into the container, trying not to get any of the dye around the edges. Finally, I shook it to mix the dye with the alcohol. Before dyeing the object, I filled it with water so it wouldn't float in the bucket.
Before you start the project, you have to wear the safety gear to protect yourself against the methanol in the ethanol alcohol. The respirator, the goggles, and the gloves.
I carefully poured the ethanol into the bucket, trying not to spill any onto the table. I placed the fingerprint object into the bucket. Don't worry if the solution overflows a bit. Remove the bottle after 1 minute and place it next to the bucket to dry.
Now that your fingerprint object is dry, find a dark room, such as a closet, put on your goggles, and turn on the light.
With the light on, we can easily see the thief's fingerprints in perfect detail. Her pointer finger, her middle finger, her ring finger, and her thumb are of perfect quality. Back at the police station, where the police are currently fingerprinting our thief, they will find a perfect match between my sample and theirs. Thief, consider yourself busted. The results. Now that I've completed my project, I can look back and determine whether or not it was successful. My main goals in order to solve my problem were: create a cost-effective fuming chamber and keep the total cost under $100. Successfully complete the fingerprinting without using professional supplies. Provide a cheap, homemade solution to make at-home fingerprinting possible to anyone. Let's find out if I met these objectives. Comparing project costs, I see a significant difference between what I paid and how much the pros paid. The most drastic difference was the fuming chamber, with mine a whole $160 cheaper at the very least. The fingerprinting was a complete success, even though I never bought professional supplies from any forensics company excepting the yellow dye. The overall cost of the project was around $65, which is relatively cheap because you can use all the products multiple times. Also, all my supplies except the dye can be found at the store or on Amazon, making it available to almost anyone. In conclusion, this project was a success. Reiterations. Since many of the things I needed, such as the dye, ethanol alcohol, and blue fluorescent blacklight are all fairly rare specialty products, buying them wasn't easy. It took a lot of time and research to be able to find products that were affordable and what I was looking for. The final challenge was my budget. Once I started, I realized that $30 wasn't enough, and instead of thinking about what I viewed was cost-effective, I needed to put it in perspective of how much professional companies pay. Once I did this, and once I got the free Amazon Prime trial for free shipping, a cost of about $60 or more wasn't bad at all.